Hello everyone, welcome you all to the video session on Model 4 Infinite Series and Power Series Solutions of your subject 18MAT21. So in the last few video sessions on this model we have studied about infinite series and also power series solution, wherein we have studied the series solution of Bessel's equation leading to Bessel function, and also you have found the value of j half of x, j minus half of x, and also you have proved the orthogonality of Bessel function. So today we are going to find the series solution of one more differential equation known as Legendre's differential equation. The series solution of Legendre's differential equation. So we have the Legendre differential equation in the form 1 minus x square d square y by dx square minus 2x into dy by dx plus n into n plus 1 of y is equal to 0. You take that as equation number 1. 1 minus x square d square y by dx square minus 2x dy by dx plus n into n plus 1 of y equal to 0. The coefficient of y double dash, that is 1 minus x square, is taken as p naught of x, and p naught of x is not equal to 0 at x equal to 0. So you may remember the method of finding the series solution of Bessel's differential equation. The same method we are following here. So similar proof will do for finding the series solution of Legendre's differential equation. First, to assume the series solution of Legendre's differential equation like this: summation y is equal to summation a r x power r varying from 0 to infinity. It's not the same, it is similar to Bessel's differential equation. So from that you find dy by dx. What is dy by dx? Summation a r into differentiation of x power r is r into x power r minus 1. So what will be your d square y by dx square? Summation a r minus 1 into x power r minus 2. Okay, this now you substitute this d square y by dx square, dy by dx and y in equation 1. In the equation 1 you substitute all these values: y dy by dx, d square y by dx square, that is 1 minus x square into d square y by dx square, that is summation a r minus 1 x power r minus 2 minus 2x into dy by dx, that is summation a r x power r minus 1 plus n into n plus 1 into y is summation a r x power r. Okay, now here you have two terms: 1 minus x square, that is 1 into summation a r minus 1 x power r minus 2 minus x square into this summation. So multiply and simplify the term. The first term is 1 into this summation, so term as it is, minus, when you multiply by x square this becomes x to the power r. So summation a r minus 1 x power r minus this term you take it inside, summation 2 a r x into x power r minus 1 is x power r plus n into n plus 1 summation a r x power r is equal to 0. Now as usual we equate the coefficient of various powers of x to 0. So first, coefficient of x power minus 2, that is, you can observe here when you put r equal to 0 the lowest power here is minus 2, right? So what is the coefficient of x power minus 2? a naught into 0, r is 0, minus 1 is equal to 0. So a naught into 0 is 0. That means to say that a naught is not equal to 0. When you put r equal to 0, a naught 0 into minus 1 x power minus 2. Right? So equate the coefficient of x power minus 2 to 0. So a naught not equal to 0. Similarly, coefficient when r equal to 1, a1 1 0 is equal to 0. So a1 into 0 is 0. That means a1 not equal to 0. Now generally the coefficient of x power r you are equating into 0. Coefficient of x power r we are equating into 0. What is the coefficient of x power r minus 2 here? r minus 2. So what is the coefficient of x power r? r plus 2 minus 1, that is r plus 1. So ar plus 2 into r plus 2 into r plus 1 minus r minus 1, coefficient of x power r r minus 1, and here minus 2 ar into r, and here plus n into n plus 1 ar. Okay, that is all coefficient of x power r. So leaving the first term, shift all other terms to the right hand side. So ar plus 2 into r plus 2 into r plus 1 is equal to, shift all terms to the other side, take ar out. When you take ar out, remaining term is r into r minus 1, here 2r, and here minus n into n plus 1. Okay, find ar plus 2. What is ar plus 2? Minus n into n plus 1 plus minus r square, minus r plus 2r is plus r, but minus I have taken out. So minus r divided by r plus 2 into r plus 1 into ar. Okay, so ar plus 2 I have written in terms of ar. Now putting, again I have written the same thing here. Putting r equal to 0, what do you get? R equal to 0, a2 is minus n into n plus 1, this term will become 0, divided by 2 into a naught, right? R is 0. What is a3? Minus n into n plus 1, a3 is r equal to 1, minus 2 divided by 3 into 2, that is 6, a1, minus n into n plus 1, that is n square plus n minus 2, r is 1, right? a1 is equal to minus this n square plus n minus 2 by factorization can be written as n minus 1 into n plus 2 divided by 6 into a1. Then what is a4? N equal to 2 minus n into n plus 1, n equal to 2 will be, this will be 6, minus 6 divided by 4 into 3, that is 12 into a2, which is equal to minus of n square plus n minus 6 is n minus 2 into n plus 3, right? So into a2 divided by 12 you have, into a2. What is a2? You substitute minus a2 minus n into n plus 2 into a naught. So simplify, a4 will be n plus 1, n minus 2, n plus 3 divided by 24 into a naught. Similarly, a5 is equal to minus n square plus n minus 25 minus 5, that is minus 12. R is 5, right? R is 5, 25 minus, no, R is 3, so this is minus 9 minus 3, minus 12. So factorize again, minus n minus 3 into n plus 4 divided by 20 into a3. What is a3? You substitute Where is your A3? Minus n minus 1 into n plus 2 by 6 into A1. So combine all the terms. So A5 is equal to n minus 1 into n plus 2 into n minus 3 into n plus 4 divided by 120 into A1. Minus into minus becomes plus. Okay. Now substitute all this in the expanded form of 2. What is the expanded form of 2? R is 0. This is A naught plus next term R is 1. So plus A1x plus A2x square plus A3x cube and so on. So substitute, since the constant A2, A4 are in terms of A naught and A3, A5 etc. are in terms of A1, we rearrange the terms as y is equal to A naught plus A2x square plus A4 x power 4 and so on, plus A1x plus A3x cube plus A5x power 5 and so on. Here it is A2x square and A4x power 4. Make it as x power 4. This is x square. So substitute all the values. A naught, if you take out from the first term, this is 1. What is your A2? Minus n minus 1 into n plus 2 by 6 in no, A2 is here, minus n into n plus 1 by 2 into A naught. So A naught I have taken out, remaining is minus n into n plus 1 by 2, right, into x square plus what is A4? A4 is n plus 1, n minus 2, n plus 3 by 4 factorial into A naught I have taken out, into x power 4 and so on. Next, from the second set of terms, I have taken out A1 out. So A1 into x minus, what is A3? A3 is minus n minus 1 into n plus 2 by 3 factorial into A1 I have taken out, into x cube. Similarly, substitute for A5. Okay. Now, let u of x and v of x respectively represent the two infinite series in 4. So if you take this as your u of x, this is an infinite series in x. This is, you take it as v of x. Then the solution can be written as y is equal to a naught u of x plus a1 v of x. This is the series solution of Legendre differential equation.